Sometimes you might get asked to use something called an enthalpy of formation when you are trying to work out an enthalpy change, and I'm going to show you why that might happen here. So what you might get asked is you might get asked an enthalpy change, and it's got a wee, basically enthalpy of formation is basically when you form a chemical from its elements. So you can see this here. So if you're trying to make 1 mole of methane, then you would use 1 mole of carbon, and you'd have to use 2 moles of hydrogen from the balanced chemical equation. However, there is something here that is actually quite important, and it's the fact that that is a C in the solid state. We said that bond enthalpies had to be used when they were in the gas state, okay? So this presents a wee problem, and I'm going to show you how we'd solve this just now. So when you do this data booklet thing, it does tell you that the enthalpy of formation, so the enthalpy change involved here, is minus 75. I'm going to show you something similar. I'm going to show you that for a ethane. I'm going to show you how to do that. But basically, for methane, we're still talking about that one, you need to change the 1 mole of solid carbon atoms into 1 mole of gas carbon atoms, okay? And that enthalpy change here, this is quite important, right? To go from 1 mole of carbon to 1 mole in solid form to 1 mole of carbon in the gas form is known as the enthalpy of sublimation. Okay, and that's when you go from a gas from a solid straight through to a gas. It's got a value of 715, and you'd actually find this on page 10 of the data booklet. We're going to use this now to work out this enthalpy change. Okay, so just as before, these ones are going to be breaking. And these ones are going to be making. These are positive, these are negative. So this is a wee bit difficult because we've got this, but we'll just go through drawing our things. This is C, we'll draw here, and then this is going to be H2. And then this is going to be ethane. There we go. What we're going to do is we're going to have a look at this just now. Oops, there's a wee H missing. And we're going to go through. So let's work out the enthalpy. Let's work out the enthalpy of the breaking side. Obviously, we've got 3 lots of this bond here because we've got 3 lots of H2. We'll come back to that when we do that. So let's start with the carbon. Notice that this is in a solid form, so we're going to have to change it to the gas form. So CS to G, the enthalpy of sublimation is going to be 716. But because it's 2 moles of carbon that's been sublimed, you have to times that by 2. That's going to end up being 1,432 kilojoules. This HH bond, you've got 1 time, but you've got it 3 because you've got 3 moles. So it's going to be, that bond enthalpy is 436, and you're going to have to times it by 3 because you've got 3 moles of that bond being broken. That's going to end up being 1,308 kilojoules. When you add that all together, you've got positive 2740. So we've done our equation. We've done our enthalpy, bond enthalpies by this side. We're going to quickly do this one just now. These are being made, so these are always going to be exothermic, they're going to be negative. We'll do a CC bond because we've got 1 of them, and we've got a CH bond. We've got 1, 2, 3, 4, 5, 6, 6 of those. This one is just going to be 348 kilojoules on its own, just 1. We've got 6 of these, that's going to be 6 times 412, so that ends up being 2,472 kilojoules. If we add all that together, that is going to be negative, and it's 2820. our enthalpy change here, just at the bottom, delta H is going to be products from reactants plus products. That's going to be plus 2740 plus minus 2820. That becomes 2740 plus 2820. So your final answer then, is going to be minus 80 kilojoules per mole. There we go. So we have used the enthalpy of sublimation there to help us because that was in a solid form of carbon. We've now found out our enthalpy, and that is us completed this example. Okay, so if you're ever asked anything about the solid form of carbon, just remember that you need to sublime it first. You need to turn it into a gas, and you'll find that in page 10 of the data booklet under the sublimation of carbon. Hopefully that makes sense, and as always, if you need any help, you can ask your teacher.